Hello, everybody. Good morning. So I'm here to talk to you this morning about continuous delivery with containers. Just some background real quick. So the first thing is that I'm between jobs right now, so everything that I talk about is totally from me. Like, I'm not speaking on behalf of any company. So I'm going to be talking about Kubernetes and GitLab and a few other things, but there's no bias here. Not that there would be anyway, but be rest assured, definitely not today. Last 2 years, I've been working with Apache Mesos and Kubernetes. Before that, I spent time working on the CI/CD pipeline for the OpenStack project while I was working at HP. And in that role is really where I got the bulk of my continuous integration and continuous delivery experience. In that role, it was all of the project changes inside of OpenStack. So at the peak, we were doing like 2,000 tests an hour against the OpenStack code base. And in that role, we were running everything on virtual machines. So it was really in these past 2 years that I've been working on container technologies that I started seeing the real benefits that containers can bring to the testing space, which is sort of what brought this talk together. And then history-wise, spent about a decade working in systems engineering. The past 2 years, I've been working as a developer advocate, so doing a lot of sort of basic implementation work of continuous delivery pipelines, which I'll talk about, but mostly doing talks like this. I've also worked on a couple of books. A lot of people who I meet at open source conferences know me because I worked on Ubuntu for several years. So I worked on the 8th and 9th edition of the official Ubuntu book. And then when I was working on OpenStack, I wrote an OpenStack book with a colleague over at Time Warner Cable. So I wanted to start off. So hopefully people here are somewhat familiar with continuous delivery. Are anyone using it right now in their organization? All right, that's a pretty good number. So I just grabbed the really basic definition off of the Wikipedia page, which is really it's just about releasing software in short cycles. Depending on the company, this could mean you're releasing every single day. You could be releasing with every single commit that you put into your master branch. Or it could be something like weekly, like that still sort of falls into the continuous delivery realm. So this is in contrast with how software is still done in a lot of organizations, where it takes a few months between releases, sometimes years. Don't end up seeing their changes very quickly. They could be like 18 months from the time, at best, when they request a feature to when they see it actually result in the software. And not only for the customers, but the developers actually lose track of what they're working on. Because when a change doesn't go to a customer until 18 months later, the bug reports don't come in until after the change has been updated. It could be 2 or 3 years before the developers are seeing their change actually in production and getting feedback. But in this world of continuous delivery, if you're looking at sort of like an example of a project workflow, the first week, is your project planning, and then you do like a super simple release of the version that you're working on. So you develop it, you test it, put it into staging, and then do a release. And then week 2, you start right into the customer feedback because you've already delivered that software to your customer. And then that's pretty much how the weeks after that go, until you're ready to either make some sort of major revision to your software. But just this workflow ends up being better for the customers and better for developers. But the main problem with this is that testing takes a while in the traditional model. People are working on branches for months at a time, and really the software doesn't come together until months or years after it was planned. So it takes a real shift in the way that you do software engineering at your company to develop a continuous delivery platform, and also do it in a way that's fast enough, which is where containers come into this. So you can tell I made this graphic because it's awful. But anyway, in the traditional CI/CD pipeline that we're talking about, CI is continuous integration. So that's all the changes going in and being tested, and then delivery is actually the launching part of it. But the idea with this is you do a git push to your Git repository. That's when it goes into this CI/CD pipeline, where the software is built into some sort of image, whether you're testing on bare metal or virtual machines or containers, it doesn't really matter. But it's built into some sort of machine that can actually run your tests. From there, the artifacts are spit out, so this can be log files, tarballs, built software if you're making RPMs or deb packages. And then that is what is tested or given to the developers as an output. Then typically it's gone into some sort of staging server before it's pushed into production. In the staging and production sections, these are of varying degrees of automation and manual processes. A lot of companies like to have someone press the go into production button. But when I was working on OpenStack, it was like YOLO. You just like push it into production, it's fine. It's like all of the documentation that we worked on, it was immediately published after it passed all of the tests and was code reviewed. So that made it really easy to not have any sort of manual intervention. But a lot of the continuous delivery and continuous integration tooling has an option to pause things. And actually the walkthrough that I'm going to show during the second half of this talk has a mechanism for that. So I'm here to talk about containers. So the way I like to frame this is, for one, I don't like the container ship metaphor. The biggest problem I have with that is, it turns out I'm kind of a nerd, and I read this entire book about containers once. And the whole point of containers is they're all the same size, and they're within some sort of weight limitation. But that's not a really good metaphor for computer containers. Containers and computers can be all different sizes, sort of weights, if you will. So I went to the Rubbermaid Flickr site, and I found this one. So like in this picture, we got some yogurt and some fruit and some two little containers. And this one with the pasta, that's got a sidecar container. You know, the beans go with the pasta. So it's sort of a more accurate metaphor for containers, as they can be all different sizes. They're very portable. You can move them around, mix them up. So first, with this doing continuous delivery, everything runs in containers. And then you can organize everything really efficiently. So I have a chart later that shows you sort of where blocks can go in containers. But the idea is that you don't waste resource space on your system. When you're running VMs, that is often the case in bare metal. Which brings me to asking the question, like, why can't I just use VMs? Like, VMs are very portable. VMs have images. They're similar to containers in a lot of ways. But they're not identical. Even in, so I used to work on OpenStack, and even in a system that you fully control, not a public cloud where when you request a server, you're not sure when it's going to come up. But even when you control the entire environment, VMs just happen to take longer to provision. Not as long as a bare metal system, but they do end up taking longer to spin up. And that's because they run an entire kernel, typically a whole version of an operating system. Even if it's a really small operating system, it still takes time to boot and load up systemd and load up all the libraries and everything. And oftentimes with testing, you don't actually need all of that stuff. You need a basic environment which has the libraries that you need, but a container image can be really, really tiny. And it's running on a host system that's already up, so it just boots it up really fast. And another thing that comes into play really important way in testing is that a virtual machine image, it's not super portable. You may be able to run it on your laptop, but the benefit of a container image is one of the reasons containers really took off was because there's this whole ecosystem of being able to run a container on your laptop in a really easy way, which is the thing that Docker did for our community. Is they made it easy for everyone to run their software locally. So the same container that is used on the developer's machine is also what's used in testing, it's what's used in staging, it's what's used in production. And since these are so easy to ship around, it makes it so we have a much easier time making sure everyone is working on the same exact thing. So as I mentioned, there's also this difference in like the utilization of the servers. So there was a study I looked at, and it said on traditional servers, either bare metal or virtual machines, the utilization tends to be somewhat low. On bare metal, it can be low as 12 to 15% utilization. So you have these servers out there that aren't really doing much most of the time because they may have just one service running on them. It's a bit better in the virtual machines. You have more like 30% utilization, which is partially because you can size the virtual machine to be the size that you need it to be for your application, instead of buying the bigger server just in case you might need that later. In a containerization platform where you aggregate a bunch of machines into a container cluster, you have, first of all, the servers aren't so siloed. There's often service discovery built in. So when you launch your Jenkins server, it automatically knows how to find your Artifactory server for where your artifacts are going to land. It often handles things like authentication. So you have uniform authentication across your applications. And then, of course, since it's a computing cluster, you are sharing the resources of all of your systems across your to run the services that you're running. And so there's a few ways to go about this. You can run every single thing that you are running in your continuous delivery pipeline on containers. Or you can use partially a legacy infrastructure. So if you're running something like Jenkins, you may be able to continue doing that just on its own server and then do all of your testing in containers. Or you can run everything in containers. So that would mean, first, this is sort of a basic container infrastructure map here. So at the bottom, you've got all of your Linux servers. And those can be on anything. These can be bare metal. These can be running on your OpenStack instance. They could be running on Amazon, Google, or whatever. But essentially, you need a Linux box, several of them to install your cluster on. On top, yeah, and then that's what you run your containerization platform, which is going to be your Kubernetes, your Docker Swarm, your Apache Mesos. And on that layer is sort of where you get your metrics. That's where you get your container orchestration and all of these different pieces that actually make your cluster operate properly. And then on top of that is where you actually run all of your services. So in this model, you're running your GitLab, your Jenkins, your Artifactory, whatever you're running in your continuous delivery pipeline, all on top of your containerization platform. And then what you're also doing is you're running all of your tests in this platform as well. So all of your little microservices are running here. And then every time it goes out to run like a unit test on your Python code or an integration test on your entire stack, that's all running in the same containerization platform. So you get help with service discovery, so Jenkins knows exactly where to send things off to because it's all done sort of locally. Or you can have separate clusters for these things. But the idea is that you only run one huge underlying infrastructure that is the clustering software for the containers, and then you don't have to worry about anything else underneath it. So what this might look like, right, so in this model, sort of you've got, in the traditional one, you've got all these different servers, a couple Jenkins servers, one running GitLab, and then one server that's totally devoted to tests. This is nice for isolation, but it's not so nice for utilization. So I just use these little colorful blocks to say, like, traditionally, one for each service, but when you containerize things, you can run these services in a more like a cloud-native microservices way, where you're splitting across the load across multiple machines. So you've got maybe more Jenkins servers, but they're smaller and they're running in a more distributed way. And then your tests just run everywhere. Or you can restrict them to certain machines and get the isolation you sort of wanted. So maybe your tests aren't running on the same server as the Jenkins server if you don't want. All of the containerization platforms have the ability to tell them what type of machine you want them to run in the cluster, and so they could be isolated to some degree. Another option is what I alluded to, is where you have a legacy infrastructure, and then you want to add containers to that. So you may have a GitLab or a Jenkins instance running already, and that's running fine, or that's run by another team. And what you're trying to replace is where the tests actually run. So you could just spin up your containerization platform just to run the tests. And this is actually similar to what I'll be showing you in a few minutes. So another option is, this is actually what we used at my last job. We had Jenkins running internally just by the sysadmin team. All of our code repositories were up on GitHub. And then we had our testing cluster, which actually ran all the tests. So in this model, you push your code up to GitHub. It notifies Jenkins that a change has happened. Jenkins is what does all of the CI/CD stuff. It runs your tests and everything. And when it runs a test, it goes out to your cluster and runs them. And then in our case, that's also where it deployed to a production cluster, but that was also containers. So the containers are shipped around based on where we're launching them. We did use a consolidated container image store. So like Docker Hub is an example. We ran our own where we upload the image, and that's the image we test from, and it's also the image that we deploy from, as long as the tests pass. So this one's actually one of the most common models because a lot of people are using GitHub. You could also use a hosted continuous integration delivery service. Circle CI, Travis CI, TeamCity, these are all ones that are free to a point for open source projects, and then there's paid versions. My last job, we used TeamCity, the paid version, in order to run our tests. These are all, of course, proprietary, but they do make it really easy to get going. And a lot of these just hook into GitHub. GitHub makes it really easy for several of these, where it's like, it'll even show you the test results inside the GitHub UI. And so really the value add of these hosted services, in addition to sort of obfuscating the configuration and the setup and the running of the maintenance, like the infrastructure for the CI/CD system, they work really hard to make really good workflows. So I see the Circle CI guys over at conferences all the time giving really simple workflow talks saying, we make it really easy for you. And then in these, like, you have sort of usually the option of running it in some sort of internal things, internal to Travis or TeamCity, or you can farm it out to a cloud platform. So you could run it on Kubernetes. The three big cloud providers all offer Kubernetes hosting solutions these days, which hook into all of these services pretty easily. So I want to show you a walkthrough, and this is the walkthrough that I have for you. So in this model, everything is hosted up on gitlab.com, which includes the enterprise edition. If you have an open source project, I think it's the gold edition that it includes if you run everything on gitlab.com and have a public project. But that's your repository for your code. It's your artifact store for things like logs and container images. And it also does the test runner, which is what goes out to your cluster and actually runs things. And again, this can be hooked into any of the top 3 clouds, or you can hook it into your own Kubernetes cluster if you're running, which is why I say, like, any of these scenarios I just ran through, you can mix them up. There's a lot of ways to go through them, and if you don't have a legacy infrastructure, you can use hosted or whatnot to move things around. And maybe you're running your production services on a cloud, but you're running all of your local tests in a local Kubernetes cluster or something. Those are all options. So I don't have a demo because this actually would take a long time to spin everything up and do things live. Also, I'm not that brave this morning. So I'm going to do a walkthrough with screenshots to sort of show you what I worked on to get a pipeline running on GitLab. It's using their tooling called Auto DevOps, which automatically sets up a pipeline and stuff. I'll show you. It's pretty cool. And then we're going to run it on Kubernetes. And I'll take questions at the end. But I can't really give a ton of answers, like specifically product-wise, lab, or the Google Kubernetes engine. But we can talk about that more. So, if you are, so first of all, I wanted to give this demo, or this partially because GitLab is an open source. It's in addition to having GitLab.com, which is hosted. There is an open source version of GitLab. Everything that I'm showing you in this is pretty much is available in the open source version. The only thing that's not is some of the tests that Auto DevOps sets up, like the ones really specific to security. Those are sort of their gold feature ones. But it doesn't actually matter for this. You can use Auto DevOps on the open source version. And then I wanted to use Kubernetes because while I'm using Google's cloud in this example, you can also hook this into your own Kubernetes cluster. So this walkthrough I'm giving, I am showing you the GitHub.com proprietary site and the Google Kubernetes, but you can replace those with the fully open source versions. So if you were to do this on GitLab today, there's a bottom of this link to the walkthrough, essentially the demo you can do yourself. But either you'd start with a new project or you'd add a CI file to an existing project. But right now, GitLab has this ability for 3 different pieces of types of code. So you've got Ruby, Spring, and Node.js. They are adding more, but this will set up a repository for you that shows you all of, that sets up like all the testing infrastructure you may need for Rails, Spring, or Node. So you can use this template when you're creating this project, or you can apply pieces of this template to an existing project, but that's a bit more manual. So I decided just to go with a Ruby project because my example is just a very simple website. So there's a few things to fill in on this page, but it's a pretty basic setup of a code repository. And then we bring in the Kubernetes bit. And this is where you actually have to log into your Google Cloud account. And it's actually really simple. We're not going to be launching any Kubernetes clusters from the Google Cloud UI itself, which is good because all of the, every single cloud platform has a really confusing UI. And Google is no exception. But they do have this quick start for getting started with the Kubernetes side of their cloud. And all you have to do really is enable the API and make sure billing is turned on, so it will actually charge you for it. And then you create a project, and then that's the project you use inside of GitLab when you want to run your cluster. But the interaction with the Google UI is really limited. And then you go back over to your GitLab project. So your code repository exists, and since we set it up with Auto DevOps, there'll now be a button that says Add Kubernetes Cluster. So you'll just want to click on that, which brings you to this page. In this one, you can either, they have like integration with the Google Cloud. So the first option is that you integrate with them, which is what I'm doing. But you can also add an existing cluster, and that allows you to hook into other Kubernetes clusters. So this makes it super easy because it'll spin up the cluster for you. But if you already have your own Kubernetes cluster or you're running on a different cloud, this is the page where you would the Add Existing Cluster tab here to actually do that instead of using the Google one. And then you add the details of what you want your cluster to look like. So you also, as I said, you have to have the cluster already, or the project already existing inside of Google Cloud. But then the cluster is all automatically configured through GitLab. So you pick the region you want it in, how many nodes you want to run it with. That's the Kubernetes nodes. And then it automatically spins it up. It takes a few minutes. And then once that's up, it's up. So in this cluster, this is really the default that GitLab offers you for your Kubernetes cluster. It's got a total of 22 gigs of RAM, 6 CPUs. So it's not, a super big cluster, but for my test, I didn't really need a really big one. And this is the UI for Google Cloud, because I wanted to have a look at it there. So the next step in this is you have to enable some things on your Kubernetes cluster. So the first one is Helm Tiller, and you can sort of think about Helm as sort of like the apt-get of the Kubernetes world. It helps you install packages on your Kubernetes cluster, which is what we're going to do. So first we have to install the package manager, essentially, and then we're going to set up the ingress controller so we can actually get to things on our cluster. So this is, ingress is the incoming network traffic, because we're going to launch something into production in this continuous, we're going to continuously deliver something. And then we add in Prometheus, which is a monitoring and metrics tool that works in cloud-native environments. So we're installing Prometheus on top of Kubernetes in order to get some statistics out of it. And that's one of my favorite parts, because it's actually integrated into the GitLab UI. So we don't have to even look at the Prometheus UI or set up Grafana or anything. It's all built into GitLab. So we have our cluster built. Our repository is all ready to run tests. And now we actually have to enable this auto DevOps thing inside of GitLab. And it's pretty simple. Like, you check a box. One of the things it needs is it needs a wildcard DNS entry in order to spin up the VMs and then access them. And helpfully, they just use a free service that, GitLab uses a free service that automatically sets up the wildcard domain for you if you don't have a DNS server of your own. So in this example, I'm just using that. And then there are some options. I don't know, there might be too small to read. At the bottom of the screen, you can have it automatically deploy to production, or automatically deploy to staging, and then someone has to push the go to production button after they review it. But they give you a few options just built into this. And again, this is like their auto DevOps tool. All of this you can edit yourself if you go back into your system, but this is just what comes out of the box. So once I have that set up, once I say OK on that, it will actually start running the tests immediately. It'll look at my GitHub or GitLab repo and launch the test that it wants to run. So this is sort of what the screen, the view pipeline screen looks like in GitLab. It really just shows you that you've got this Rails template and that things are starting to run. But the interesting part is what it sets up for you automatically. So this is what the pipeline looks like. You've got your build stage, which is going to grab the base of your container, add everything into your container, including your code, and then create that container image. In the testing area, it adds various types of tests. And I'll show you in the next slide, there'll be a description of what each of these are. But essentially, it's testing code quality. It's scanning your container for security vulnerabilities, doing some light license management with a really basic licensing scan, and then whatever unit tests and other things that you have defined in your project. And then I don't have a staging server, so it's just launching everything into production once these tests all pass. Once that's done, it also does this little really super basic performance test. But again, this is just the defaults, so you can edit this as you see fit. But I love this screen because I've spent the past 6 years manually writing pipelines. So to go into a project like GitLab, which is open source and offers all of these tooling, and automatically just brings up this pipeline for me that does all of this stuff, I'm like, oh, that's so much nicer than a Jenkins file. I mean, I will have to go in eventually and edit this myself to refine it to be actually what I want it to do. But just having this out of the box is really satisfying. And of course, with the proprietary versions and things that are hosted on CircleCI and Travis and TeamCD, they also have this sort of workflow to make it really easy for you to start on their platform. And then this is actually just a screenshot from their documentation going into exactly what all of these tests are doing. So you can, in addition to being able to read them because they're in your code repository, you can sort of just eyeball this and see, like, do I want to do dependency scanning? Sure, or no, maybe I don't. Maybe I have a license management system that I'm using, so I don't need to use the one that came out of the box with this one. But it just gives you a rundown of how each one's working, or what each one does. So this is what happens after you've run your pipeline and it's been deployed. And this big red arrow is pointing at the important part of the screen that I wanted to bring your attention to. The little very small, arrow coming out of a box, that will bring you directly to your deployed application. So you can see it running in production, or if it went to staging, it'll show you where you're going. The one next to it with some little bars, that's your metrics. So that'll show you all the data coming out of Prometheus. I'll show you that in a moment. And then the really cool one, they're all really cool, but the third one is your terminal, which will give you a terminal on the container where your application is running. And that's really useful if you want to poke around in the container and see what it's doing. When I was working on Mesos, they've actually made this a lot easier over time, but it took a couple of hops to get inside of a container. So that was like first you SSH to the master node, and then you go into the other ones and actually list all of your containers, find out which one it's running on. But this is just in your web UI, and it's quite nice. So first, this is my website that I just launched. Yay. Obviously, super basic. But this is the one that would have deployed after that pipeline ran. The pipeline took a few minutes to run. It's not running a lot of tests. And then this is your metrics that came in from Prometheus over on the Google Cloud. So it's just reading from the Prometheus API to pull this and put it into your dashboard. So in this one, we can see the throughput. This is me just like refreshing the demo page a few times. And so you can see like where that's spiking over the 20 minutes I had this thing running. And of course, you can edit what sort of statistics come in, because Prometheus can gather a ton of stuff about your infrastructure. But in this one, this is just the Nginx stats for the service that I'm running on Rails. And then, of course, we can make a change to our project. So in this change, I wanted to change the message on the little website that I'm running just to welcome the All Things Open crowd here. So I did a quick commit, and then it automatically runs the jobs again. One of the nice things about having an integrated platform for this is that you can have like notifications of when something is triggered. I used to do demos with Jenkins, and I'd have it like just hammer GitHub like once a minute, like cron style, like star, 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 star. But with GitLab, since everything is like all together, your CI, your job runner, and your Git repository and everything's all together, there's more internal magic happening there, so you're not just hitting your Git repo all the time, which is fine for like 3 projects, but once you get to 3,000, it turns out GitHub throttles you. So as you can see in this one, there's actually a few more steps to the pipeline because it's the second time I'm running it. But it's essentially pretty similar tests. They all get run again, and then you deploy your application again. And then I wanted to add this one in because I didn't show you before. If you look, when you click on one of these, it'll show you what's going on with the test, and you have this nice little UI of what's going on. So this is when I clicked on the production job, the deploy to production job, and it just gives you the console of how the test is running. So if you're really impatient and you're like, why is this taking forever? You just click in the UI and it brings you to the console. So you can see that. And then the logs are also stashed later when they're not running live, so you can go back and find out what went wrong if one of the tests failed. And then we've got our successfully deployed application, which now has a welcome to All Things Open attendees. So let's see what our time looks like here. Yeah, we've got a few minutes. So that was showing you how you can run GitLab either on-prem or on gitlab.com for your CI/CD pipeline. And then it ran out to Google Cloud to actually run all of those tests and then deploy the container into production. And I started playing with this. I was trying to figure out like which demo and which walkthrough I wanted to do for this talk. So I played around with a few platforms, but honestly, like for this walkthrough, it took me about 3 hours to get familiar with the whole thing. I'm sure if you talk to the GitLab guys, they're like, it takes 5 minutes. But to really have a fundamental understanding of like what's going on with Kubernetes and how everything is connected, it took me about 3 hours. And that is a really short amount of time to go from like not being very familiar with the tooling at all and just having a vague idea about CI/CD to actually deploying an application. So they're doing a really good job over there. And of course, it's open source. So it's not just using a platform where they're trying to make things easy because they want you to pay them. So the last thing I wanted to talk about was these advanced strategies for continuous delivery, which so there's not just the model of deploy to staging, deploy into production. There's common ones. The first is doing canary deployments, where you deploy your application to a small subset of your users. So in the containerization world, this would typically be like 3, 5, 10% of your containers get replaced with the new version. So then when people hit your load balancer, they're going to get sent to one of the containers, and it could be the 90% still running on the old one, or the new percent running one of the new 10%. And this is sort of to see if people, this is like testing in production, right? Like you're seeing if your users are running into the problems, or if they have complaints, or if there's all these failures throwing up in your log files suddenly when you do this canary release. And the thing with this is it's really easy to roll back and just shut down those containers and go back to the ones you were using before. Oh, and the link that I give here on Martin Fowler's site, he has this really great article about canary deployments, so I'll share these slides afterwards, but it's really good. It's a really good read if you want to look at it. And he also wrote one about blue-green deployments. So in a blue-green environment, you have 2 production environments, but only one of them is live at any given time. So what you do is you upgrade the entire system on your blue. Once that's upgraded, you make that one your live, and then you make your green one, which was previously your production system. You make that one like your really hot standby. And so once you decide that blue is looking good in production, then you can update your green side independently. So you don't have downtime. You just switch your load balancer to look at the other production cluster. And if things go wrong, you have that hot spare of the old version still running, at least for a certain amount of time until you decide to upgrade it. And this pretty much, you don't have downtime because you always have 2 production environments running. The obvious downside is you have 2 production environments running, and that is a lot of resources to devote. But it actually works for a lot of organizations where the resources are less of a problem than doing a really messy rollback. And again, with containers, this is sort of a really easy thing to do because you're just, every time you do an upgrade, you're not logging into a server and running upgrade commands. You're just shutting down containers and replacing them with the new version in sort of a golden image style deployment. And so for all of the containerization platforms, there are mechanisms to do this. One of the tools that I worked a lot with in Apache Mesos and DCOS was VAMP. So in DCOS, you've got the scheduler called Marathon, but you have to be really, really good at writing Marathon configs to do one of these sorts of deployments. So VAMP is a company and an open source project that allows you to do these blue-green deployments on Kubernetes and DCOS in a really simple way without having to write really complicated config files. And they just had their 1.0 release recently. So it's actually looking really cool. So you can do these advanced deployments in these containerization platforms. It's not just a thing you can do with VMs anymore. So I want to leave a few minutes here at the end. I think we've got 5 or 10 minutes just for questions. There is a microphone, and we have our charming volunteer here who will run around with it for me. But if anyone has questions. Anybody? Comments? Experiences? There's one, well, of course, far away. Do we have?
Just trying to help you break the ice. Can you hear me?
Yep.
Okay. So you talked a little bit about blue-green deploys at the end, and earlier on you were talking about Kubernetes. So when you deploy that, does that still give you blue-green deployments for free?
So the question was I was talking about Bluegreen Deployments at the end, and if you get that automatically when you run Kubernetes like out of the box. No, you still have to configure Kubernetes to do that sort of deployment. I mean, yeah, you can. It's easy to do on the platform, but you still have to tell it. Like you run 2 different production deployments. You can run it even on 2 different Kubernetes clusters, and then you essentially just have identical ones, but one's been upgraded and one's been not. But yeah, it's pretty simple, and especially since like a lot of organizations already are running a whole bunch of Kubernetes clusters anyway. It's actually a pretty common way for them to run it that way. Yeah. That one in the back there.
Is it audible? No?
Yeah.
Hi. Hey, Elizabeth, good morning. I would like to know about the container. What kind of application you can deploy over there?
Yeah, so what kind of applications you can run on containers?
Like database, VS, NoSQL, so.
Yeah, so this is a very common question. So of course, containers, they all started out by just doing stateless services. So really just like your web front ends and other things that didn't have to do with like databases and complex data applications. But if you're keeping up to speed with like the latest things going on with containers, is stateful applications are like the biggest focus of pretty much every containerization platform that I've worked on. So like Kubernetes is working really hard on stateful applications. Mesos has been doing a lot, and I think they're actually like at the moment a bit further along. But the goal is to run everything on containers. I think there's even some there's some distributed databases projects that are being run to run on containers. Because even as recent as last year when I was at MesosCon, almost exactly a year ago in Europe, there was people were mostly running like their Ceph cluster outside of their Mesos clusters, and they were still running like their old NASs and things. But increasingly, it's becoming very common to run it. So what I'd recommend is if you were thinking about running everything in containers, just look at what's going on in the community and in these projects and find out what the current state of it is, because they're making a ton of progress, and it's what everyone wants. Like they don't want to have their own Ceph cluster over here and their own, Kubernetes cluster over here, So it's definitely a goal, and they're making progress. All right, thank you.